So we want to look at the ability to describe a line in space, and so we're going to start by thinking about what is needed or what is necessary to uniquely determine a line in the plane. Now, you learned in algebra that the necessary pieces of information are a point and a slope. So how can we extend those ideas so that we can work with lines in space? That's what we want to explore right now. So, different ways of writing a line. If you'll notice, there's quite a list of ways to write the equation of a line or to describe a line in the plane. We've got slope, intercept, point, slope, point, point, and standard. And those four forms you've seen before in an algebra class. The last three you're probably less familiar with. They're parametric, symmetric, which is rarely used in the plane, and vector form. But notice that those last three forms are actually going to be more powerful for us because they actually allow us to also extend them so that they work in space as well as in the plane. So let's go back and revisit what we know about lines in the plane. And first of all, let's think about slope. Now, slope is used to determine the direction of a line, and it's the ratio of the change in y over change in x between any 2 points on a line. And the ratio known as slope works well in the plane because there are only two coordinate directions that must be compared. We know that in space there are three coordinate directions, so the idea of using a ratio as a comparison is not applicable because we cannot form a ratio. So the point is important because it fixes the line to a specific location on the plane. There is only one line that has a specified slope and passes through a given point. And you can see there a generic way of writing the equation of a non-vertical line, and specifically this is the point-slope form of the line. So in parametric form, the same line can be written as x equals x naught plus delta x times t, and y equals y naught plus delta y times t. And notice we're using much of the same information as we were before, with the addition of this parameter of t. This parameter of t allows us to move points along the line, or to select many points along the line. So let's go ahead and look at the equation of the line. Y equals negative 2/3 times the quantity x plus 1 minus 4. In this form, we can identify x naught as negative 1. We can identify y naught as negative 4. We can identify delta y as negative 2 and delta x as 3. So I can write the equation of this line in parametric form by saying x equals x naught, which is negative 1, plus delta x is the denominator of the slope, so that's 3 times t, and y equals y naught, which is negative 4, plus delta y, which is the numerator of that slope, so negative 2 times t. And here we have the parametric form of that line. Now, that parametric form we can also extend and manipulate, and if I take my equation and solve for t in each of these, I would get x minus x naught, and then I would divide by delta x, so I would get t equals x minus x naught over delta x. And similar for the second equation, solving for t, I would subtract y naught, and I get y minus y naught over delta y. Now, because these equations are linked together and the x and the y values belong on a single line, these values of t, or the values of the parameter, are really important, and they are that linking, that common piece that pulls those two equations together. So if I have a specific value of t, it will produce an x and a y that are linked together. So down here in these two equations, they are linked together, and so they should produce the same value of t. So I set those two equations equal to each other, and this produces the symmetric form of the line. So if I wanted to write the symmetric form of my line, I would write x minus x naught, but my x naught was -1, so x plus 1 over delta x, and my delta x was 3. Equals, and then it's my y minus my y naught, and my y naught was -4, so that's actually y plus 4, over my delta y, which was the numerator of that slope we saw a few minutes ago, and that would be -2. And this is how we would write the symmetric form of the equation of that line in the plane.